Hello students, welcome to lecture of kinematics and theory of machine, and we are going to continue gear train. And in this lecture topic we will cover is compound gear train and reverted gear train. Okay, let's start this lecture. This is our second type of gear train, in which when more than one gear on a single shaft. You can see here in last type of gear there is only one gear on a single shaft. In compound gear there is a more than one gear on a single shaft. Okay, so you can see here this. Okay, you can see here this second shaft on which there is a two gears, this one and two. Both are mounted on this shaft. Okay, this is the driver which is connected to, this is the gear number 1 which is connected to 2, and 2 and 3 are on the same shaft, and 3 is connected to gear number 4. So this is the output shaft and this is the input shaft. Okay, so this is the second type of our gear train, in which you can reduce the RPM with large number without using the larger gear. Okay, how you can I am giving you an example. If assume that RPM of this driver is a 200, it is connected to larger gear, more teeths are there, means RPM will be reduced. Okay, 100, and these two gears, one, 2 number and 3 number, both are on a same shaft. So RPM will be same for both gear because they are mounted on a same shaft. Whatever the component assemble on a single shaft, if I am assembling some pulley here or brake or clutch, whatever the element on a single shaft, RPM will be same for the all. Okay, so this gear is connected to number 4 and this gear is larger than this number 3, so RPM will be reduced and it will be 50. So you can see here from 200 to 50 without using. If I want to simple gear train, there will be larger gear I have to use with respect to this. With respect to 1, 4 will be larger because of they are on a single shaft. And in a compound gear you can assemble, you can mount the 2 gear on a single shaft. Okay, so this is the compound gear train. The larger speed reduction from the first shaft to the last shaft obtained with the smaller gear. Okay, this is the figure from your book, our book RS Khurmi. So you can see here this is the gear number 1 which is connected to gear number 2. This is the gear number 2, and behind that you can see that gear number 3. You can see here gear number 2 and gear number 3 are on a same shaft. Okay, so gear number 2 and 3 on a same shaft. 3 is connected to, how you have to check this, because during the example this type of complex configuration will given and you have to find that which is moving which gear. 1 is connected to 2, 2 and 3 on a same shaft, 3 is connected to 4, 3, you can see here 3 is connected to 4, number 4, and 4 and 5 on the same shaft, and 5 is connected to 6, and that's how this motion is driver is delivered to the driven. And in this particular figure RPM is increased. Okay, because driver gear is in a larger size. Okay, so first of all we have to find the how means if I am giving like this is the RPM of N1, what will be the RPM of N6? Because you have derived the formula for the simple gear train, but now we have to derive the speed ratio or velocity ratio for the compound gear train. Okay, let's start speed ratio or velocity ratio for the compound gear train. Okay, velocity or speed ratio for the compound gear train. So first of all, you have to understand which gear is connected to which one is connected to 2, 2 to 3. Check this figure and we are going to step by step. First of all, 1 is connected to 2. Gear number 1 is connected to 2. Consider this only 2 gear. Among these 2 gear, 1 is a driver, 2 is a driven. So we can find the RPM of gear 2 by simple relation. N1 upon N2 is equal to T2 upon T1. Okay, and then gear number 2 and 3. Gear number 2 and 3 mounted on a same shaft. So RPM of this both gear will be same. Okay, and then gear 3 is connected to gear 4. So RPM of gear 4 will be, we can find by the using the this relation simple from the simple gear train. RPM of driver, RPM upon RPM of driven. Some student ask, sir, 3 is a driver or not? For particular in this case, gear number 4 is a driven, and gear number 4, gear number 3 is a driver. So between these 3 and 4, 3 is a driver and 4 is a driven. Okay, so we can write this relation 3 by 4 N3 upon N4 is equal to T4 upon T3. Now 4 and 5, you can see 4 and 5. This is gear number 4 and 5. You can also see here single shaft, and 4 and 5 is on a same shaft. So what will happen? Their RPM will be same. Okay, N4 is equal to N5, and 5 is connected to 6. This 5, gear number 5 is connected to gear number 6. So what will happen? 5 is connected to 6. So between them we can apply this relation N5 upon N6 is equal to T6 upon T5. Okay, consider this equation as a number 1. This relation is a equation number 2, and this number 3. Using these 3 formulas, we can write by multiplying these for these 3. You can write this N1 upon N2 is into N3 upon N4 into N5 upon N6 is equal to right side portion of all 3. Okay, among this you know that N2 and N3 is equal to same value, so you can cancel out N2 and N3. You also know that N4 and N5 is same, N4 and N5. This is the value of RPM which is same. Okay, but in teeth there is a no similar value. So you have derived this N1 upon N6 is equal to T2 upon T1, T4 upon T3, T6 upon T5. Okay, so you can see here what are these gears and which are these gears. You can see from these 3 relation. You can see this from these 3 relation that T2 is a driven. For between 1 and 2, 2 is a driven. So T2 is in a upper side, and for this T4 is driven, and in this T6 is driven. So all driven gears are in this condition. So we can write this formula is this speed of the first driver means this, and speed of the last driver, last follower or last driven. So N1 upon N6 last driven, we can find the RPM of directly last gear by using this formula. In this is a product of number of drivers. During this transmission of motion, the gear which are the driver which transmitting the motion to the second gear, which is considered as a driver, and in below will be all the drivers. Okay, so this is the relation we have derived for the compound gear train. Our type of gear train is a reverted gear train. It is a minor change in a compound. It is one type of compound also. Okay, so first of all remember what is the definition of compound. two gear on a single shaft, then it is considered as a compound. And what is the definition for the reverted? Check this out. When the axis of the first gear and the last gear are coaxial, then gear train is known as a reverted gear train. So first driver and driven will be coaxial, means check this figure so you can understand very well. You can see here this first gear is a driver, so you can see the first gear, it is the driver which is connected to gear number 2, and gear number 2 and gear number 3 both are on a single shaft. You can see this is the shaft, and gear number 2 and gear number 3 on a same shaft. Okay, so that's why it is also known as a one type of compound. Reverted is a one type of compound. But what is the change? This 3, gear number 3 is connected to gear number 4, and you can see the axis of this 1 and 4 is a coaxial. Okay, remember that shaft is different. You can see properly in this second figure, shaft is different, but only consider this axis of these two shaft is the same, so it is known as a coaxial. Okay, you can consider among that this is the number 1 driver, number 2, number 3, and this is the number 4. Our output is here. Both gear are coaxial, means in a same line. So this is the known as a reverted gear train, and same formula will be used here. If you want to find the relation between if you want to find the relation between the driver RPM and this gear number 4, so this will be same as a compound. This will be N1 upon what will be N4 is equal to driven upon driver. Which are the driven in this case? This given gear number 2 and gear number 4, so T2 upon T4, and in bottom there will be T1 into T3. Okay, this is the application of this reverted gear train. It is used in automobile transmission, lathe bake gears, industrial speed reducer, because this in axis will be same and RPM is reduced in the same axis, so it is very useful in industrial speed reducer in clock. Like you know that minute and hand hour hand, which are coaxial on a single shaft, they all are mounted, but they have different RPM, or you can say the speed of moving, so they all are coaxial in a clock. Okay, so this is the application, some applications of reverted gear train. And you know that gear ratio, speed ratio for the reverted will be same as a compound, because there is no much change in this. Only what we have done, the output or driven gear is a coaxial with the driver. Okay, check this out. We will find this this one is connected to 2 and 3 on the same shaft, and 3 is connected to, you can see here 3 is connected to 4. So that's how they transmit the motion, and the gear speed ratio is here. N1 upon N4 is equal to T2 and T4. T2 and T4. T2 is a driven, means it is rotated by the motion of the gear 1. So 1 is a driver and 2 is a driven. For this 2, okay, and 2 and 3 on the same shaft, and that's why 3 is rotating, and due to 3, 4 is rotating. There will be no relation between 2 and 3 because they are on the same shaft, so RPM will be same for the both. So there is no any relation, this type of relation for the 2 and 3. Okay, so N1 upon N4 is equal to T2 into T4 upon T1 into T3. So there is also one other relation used in a reverted gear train. You can see here center of the shafts. means you can see the center shaft of gear 1 and 4 is the same, and the axis or center line of 2 and 3 is the same. So what can I say? You can see this. What is the radius of the gear, this gear 1? When this is the radius of the gear 1, and you can say this is the radius of gear 2. So sum of gear 1 and 2 means sum of radius gear 1 and 2 is equal to, I can write that radius of 3 plus radius of 4, because there is a center line is there. Okay, so I can write R1 plus R2 is equal to R3 plus R4, and the radius, or I can say the diameter, is with respect to teeth, number of teeth. Larger the radius or diameter, the number of teeth will be large. So I can write this in a form of T1 plus T2 is equal to T3 plus T4.